Hello everybody, welcome to Chemistry Lab. Today we're going to be doing the gas laws experiment. It's fairly straightforward and simple. It won't take very much time. What we're going to be doing is measuring the change in volume as the pressure is changed, testing Boyle's law. And then you will be provided some data for temperature that will be used to analyze Charles' law, and you will be making graphs for both of these data sets. So the first part of the experiment is part A. The materials required are a plastic syringe and wooden blocks, shown here, and 5 reams of paper, each weighing 5 pounds. What we will be doing is assembling an apparatus that allows us to measure a gas volume in a closed container, the syringe, and the pressure will be provided by the weight of the reams of paper on top of the syringe. So the first step says to remove the cap from the bottom of the syringe, like so, and to remove the plunger so that we can measure the diameter of the syringe. So that's what we'll do first. We have a ruler here and the syringe entrance. If we put the ruler at the edge of the syringe, you can see that the diameter is 2.3 centimeters. Once we have measured the diameter of the syringe, we need to take the plunger and put it into the syringe at exactly 30 milliliters, which will be our starting point, and the bottom of the syringe will be at the 30 milliliter mark. Now that is placed, we put the cap on the bottom to hold it. This seals the pressure inside. And then, for added security, this wooden block has a recessed hole in it. When it's pressed down in, there's no way for the cap to escape, no matter how much pressure we put. And then we have this other wooden block that can neatly place itself on top. And make sure that the syringe is still at 30. We might have to adjust it a bit to keep it exactly in the right place, because the wood block has some weight to it. So it becomes a little bit difficult to situate, but we get there eventually. So now that we have our wood block situated, we can record the volume, which is 30 cubic centimeters or 30 milliliters. And we can now start placing reams of paper on top and recording the volume each time. So the first one we'll place like so, make sure it's balanced. You notice that the volume has decreased from 30 milliliters to 18 milliliters. Now we're going to add another ream of paper. Now we have decreased to 16 or 13 milliliters, and the previous reading was actually 19 milliliters, not 18. Now we add another ream of paper. Just to balance it so that it doesn't fall, we have 10 milliliters. Now adding a fourth ream, this becomes a little bit difficult to balance, but we'll manage. That ream brought the total volume to 8.5 milliliters. And finally, ream number 5 brings it to 7 milliliters. So you notice that that relationship is not exactly linear, which you will discuss in your lab report when you do graphs of this data. So now I'm going to remove these reams of paper. And lo and behold, the volume has, given a little bit of time to readjust, it goes back up to 30. Well, it actually goes back up to 29. So that might mean that there was a little bit of gas that escaped in this experiment. So that's part A.